Welcome back. We begin this unit by studying arithmetic and geometric sequences. The objectives of this video is to define a sequence. We will talk about some vocabulary as it relates to sequences, and then we'll generate some terms or values in a sequence given some formulas. So as you can read here, when you think of a sequence of events, you likely would consider what happened first, second, and so on. So kind of things in order. In mathematics, the word sequence is also used in the same way. Some list of numbers has a first element, a second element, third element, and so on. One famous example is known as the Fibonacci sequence, is found throughout nature, and that sequence is shown here. Can you discover the rule for the next term? And we can talk about that in class. Let's define a couple sequences here. An infinite sequence is a function whose domain is the set of positive integers. So when we do a sequence, we're going to count generally by ones, and we'll have the first term, the second term, and the third term, and so forth. We won't have negative terms and that kind of thing. Now we will sometimes have the zeroth term, and we'll study that as well. So the function values are the terms of the sequence. If the domain of the function consists of the first n positive integers only, the sequence is a finite sequence. So a finite sequence is going to have a definite beginning and a definite end, whereas an infinite sequence just continues on forever and ever and ever. The nth term of a sequence is kind of the general term. We will see also the kth term. So sometimes we'll talk about the nth term of a sequence and the kth term of the sequence, and that'll help us differentiate, which term that is. So we might say the first term is 12 and the sixth term is 24. That would be the nth term and the kth term. So a finite sequence, we talked about that has a definite or a certain number of terms. And the term of a sequence is each number of the sequence or where it falls. I've talked about that already. The fifth term is the fifth number in the sequence. So let's follow some examples. We'll generate, we've got a formula for a sequence. We'll find our own formulas in a little while, but right now we're just going to give you the formula and find term a sub 12. So we want to find the 12th term of the sequence. So a sub 12, or the 12th term, is equal to 12 times n. Our n is 12, so 12 times 12 plus 3. So a sub 12 is just 144 plus 3. So the 12th term is 147. In example 2, we want to write the first four terms for each sequence. So what we want to find is a sub 1, a sub 2, a sub 3, and a sub 4. So that will be the first four terms of the sequence. So n is 1, so 3 times 1 minus 4, and 3 times 2 minus 4, and 3 times 3 minus 4, and 3 times 4 minus 4 will represent our first four terms. So negative 1, 2, 5, and 8. And if you notice that each of these are 3 apart, well, that 3 and that 3, those are not coincidence. That's our common difference between those terms. And we'll talk about that when we talk more about arithmetic sequences. In sample B, we want to find the first four terms. So a sub 1 equals 5 plus negative 1 to the first power, and a sub 2, and so forth. What you may notice in this example, since we're taking negative 1 and raising it to a power, first one is an odd exponent, The second one is an even, the next one is an odd. So we're going to have alternating signs here of -1. This is going to become 5 minus 1, and then 5 plus 1, and 5 minus 1, and 5 plus 1. So gives us a little bit different pattern to our sequence. In sample 3a, we've got a sequence of 4 plus n minus 1 times 5. So we want to find the first three terms, which is just a sub 1, a sub 2, and a sub 3. So 4 plus 1 minus 1 times 5, 4 plus 2 minus 1 times 5, and 4 plus 3 minus 1 times 5. So 4, 9, and 14 are the first three terms in that particular sequence. In fact, you'll notice that 3a and 2a are very similar. We are multiplying some quantity by 5, and we have a common difference here of 5. And in B, we just want to find the 11th term. So use your notation, a sub 11. So we know we're looking for the 11th term, equals 4 plus 11 minus 1 times 5. So 4 plus 10 times 5, and that is equal to 54. So that's an introduction to sequences and finding particular terms in a sequence and using the formula for a sequence. And we'll get some more practice with this when I see you in class.